My name is Simon Elmir. I'm a production engineer with the artificial intelligence team at Facebook. That means we keep the AI systems up and running and healthy. So I'm going to give a talk a lot about being more efficient and productive on the command line. This talk is based on a series of internal talks that we provide optionally to employees at Facebook, and a couple bits of context about the onboarding process at Facebook that will help illustrate some of the things that we'll be talking about a little bit later on. All of the engineers at Facebook go through a boot camp. So this is a few weeks at the beginning of your working at the company, where you're just learning how to use Facebook systems, a little bit about our culture, and about the tools and techniques that you'll need to do your job. For engineers, especially infrastructure engineers like myself, who do a lot of work on systems and a lot of coding, we have development servers that are outside of the office. So our development servers are in the data center, and we connect remotely to them to do our work. Efficiency, especially on the command line, I want to cover three things. Efficiency is about, number one, being faster. If there's something that you're doing that's taking a lot of time, especially if it's tedious or repetitive, then that's probably something that the computer is going to be better at doing than you are. So if you find something that you're really annoyed about, like you're just running the same command again and again with a slight variation, try and get the computer to do that for you. We'll talk a lot about using history a bit better. So this is to help reduce mistakes. Like if you've done something more than once, you've created some complex arcane command that did exactly what you wanted. You want to be able to get to that again later on so that you can reuse it later. And since you've gotten it correct in your first iteration, you're much less likely to make a mistake if you're just retrieving it from your history afterwards. And also, efficiency is about health. One of the engineers who created this class at Facebook had problems with carpal tunnel syndrome and repetitive stress injury. His doctor advised him that he should avoid typing for 6 weeks. And for an engineer whose day job is to code and type, that's not great. So we'll cover a few different areas where we can be more efficient. Don't feel like you have to use all of the tips and tricks that we're going to talk about in the class. Pick as many as you like, as few as you like. If you find customizations that work better for you, it's perfectly fine to disagree with me about all of these things. It's just about presenting what you might find useful. So we connect to a lot of remote servers at Facebook. And one of the first things that we recommend to engineers is to use an alternative to basic SSH. So I have in my shell over here, I'm connected to a remote server. If I'm running some super important command on this remote server, so super important command, and then I go and do something silly like, I don't know, suspend my laptop. Normally, with a regular SSH connection, breaking that network connection between you as the client and the server actually hosting your application on the remote side would be killed. Like if you're running a text editor, it would kill your text editor, for example. I'm going to do something like this. I've just turned off the Wi-Fi on my laptop. And since I'm using Mosh instead of SSH, it gives me this convenient message at the top of the screen. Mosh is complaining that the network is unreachable and that it's been a little time has passed since the last communication between my laptop and the server. If I were to suspend my laptop and connect to a different network, that would certainly break a conventional SSH connection. But if I turn on my Wi-Fi, it'll take a few seconds to reconnect. But what Mosh is going to do is it's going to automatically reestablish the connection, even if the IP address of my laptop or even the network of my laptop has changed significantly. So we've reconnected to Wi-Fi, and now my application continues to run. I've automatically reconnected. I don't need to re-authenticate. Mosh is taking care of that all in the background for me. So how you would do this, Mosh is essentially a drop-in replacement for SSH. It's available in many of the standard repositories for many Linux and Unix distributions. It takes much of the same syntax as SSH. So here I'm just running Mosh, and I'm logging into my machine at example.com. Type in my password. I'm now connected with Mosh. and now this connection is resilient against interruptions on the network. Mosh is also especially good when network quality is very poor. So if you are on a train or on a shuttle and you're tethering to your phone, desperate to fix some issue on a production service, the quality of your connection, you don't want to like risk a command that you're running dying or being killed because you've lost connectivity. Mosh is extremely good at resuming connections, and it has buffering both on the remote side and on the local side, so that like CMatrix runs an animation, I didn't have to watch the remainder of that animation play out in full during the time that I was disconnected. It just shows me the latest data, the most recent frames, and if I'm watching a log or I print out too much data, I can hit Control-C to like cancel or kill that process, and Mosh will make sure that that connection goes through. In addition to Mosh, we have another utility. It's less common in package repos, but it's Eternal Terminal. It's similar to Mosh. Like Mosh is a little bit better at poor quality network connectivity, but Eternal Terminal has a richer feature set while still providing that resiliency against network dropouts. So Eternal Terminal supports things like X11 forwarding, port forwarding, where Mosh doesn't. But what if you've connected to a remote machine and maybe you want to maybe you're connected to a remote machine on your desktop at work, and you'd like to connect to it on your laptop when you're at home. If you have a single connection using Mosh, for example, you're going to be connected to like a different session when you're on a different machine. So on my local instance here, we have a set of utilities which allow you to reuse a connection and to split a single connection into multiple applications running on the remote server. The traditional applications for doing this are tmux and screen. Both of these utilities have been around for a very long time. I personally prefer to use a wrapper around those called byobu, which is the Japanese word for folding screen. So what byobu is going to do is it's going to launch tmux with my favorite configuration. And now I can control the remote session that I'm logged into in a number of interesting ways. Every command that you send to, in this case, tmux, is going to at first be triggered by a special keyboard combination. So the bind key, by default in tmux, it's Control-B. When you first launch byobu, it's going to ask you whether you prefer Control-B or Control-A. Because of some of the shortcuts later on in the slides, I personally recommend Control-B to use as the bind key. But you would press the bind key followed by one of the other keyboard shortcuts on the slide. So if I press Control-B and then I type a C, what that's going to do is it's going to create a new window inside this connection. So I just hit that keyboard combination, and now I have, you can see in the bottom left corner of the display, I have session 0 and session 1. Anything that I run in one session, I can then toggle back and forth between my windows. So the next shortcut on the slide, so I'd hit bind key and then N and bind key or P to tab between each of the sessions that are currently running. So I have one terminal currently running CMatrix. If I hit bind key N, then I get to see my other session. Maybe I want to run top. I hit the bind key and C. I create another session. So now I have 3 things running on this server at the same time. I've only authenticated to the server once. I only have one network connection active, but the server is going to keep this state for me. I've mentioned that you can use this with multiple different machines. So I can disconnect from a tmux session. Bind key D will disconnect me from that session. And if I ever want to reconnect and resume that session, like I still have applications running on that remote server, I would just run byobu again, and it resumes exactly where I had left off, where I have my session of top and my session of CMatrix still running. This is very useful if you have, you want to like switch from your desktop to your laptop. I've fixed things in production even on my cell phone. Like I've already had a byobu session running on my development server. I've logged into it from my cell phone. I've already got all the utilities sort of running and monitoring what I like to monitor, and so it's very convenient. It's worth mentioning that the bind key followed by a question mark will give you the documentation for all of the different bindings that are currently configured in your terminal emulator, in your terminal multiplexer. So this is the full list of documentation. You can check out the man page for Byobu or the man page for Tmux for a lot more details. The site for Byobu is in the QR code on the display. So history. By default, Bash keeps a listing of all of the commands that you've recently typed. I'm going to print out the last few commands that I've run. Some of these are pretty obscure and obtuse, but this sed command, for example, this is something that I wouldn't want to have to remember and wouldn't want to have to reference because this is a very complicated regular expression. So if I wanted to rediscover, like, how did I do that regular expression, there are two things that I did to make this easier for myself. One of them is you can just hit up repeatedly. This is part of the default configuration. So pressing up repeatedly will give you commands that you've recently typed, and I can get back to this sed command that I mentioned. There are easier ways of doing that, however. So if I type Control-R, this is going to give me reverse incremental search, which means anything that I type, it will show me the most recent command that contains that string. So if I type S, I'm going to get something having to do with history. If I type E, as in SE, then it finds, oh, something in my previous history contained S and E next to each other, which is my sed example. But I've done something even more to give myself a better chance of finding this command, and that is I put a comment at the end of the line. So let me just find this in my history again. So anything after the hash mark in Bash is a comment. Because I know I'm going to want to reference this command again later, I just put a comment at the end of the line. It's my sed example. So if I want to find it again, I can just reverse search for sed example. And as I'm typing it, it will find that because it's in the comment. That doesn't change the behavior of the command, but it makes my own personal history a little bit self-documenting. You can, if you have multiple commands that match, like you have multiple sed examples, like I run sed somewhat frequently, so I'm going to type sed, and if I press Control-R again, it will rerun the search with the same string. It'll just go further back in my history. So sed appears twice on this line, so it highlighted the other sed. Here's another sed command that I ran, and if I keep pressing Control-R, it would keep giving me results from my history that contain that string. If I've accidentally gone too far, like I want to get back to my sed example, which is newer than this in my history, I can hit Control-S a couple times, and that's forward incremental search, but with a huge asterisk, which I will talk about on the slide having to do with STTY. Another one of the really nice shortcuts for searching through history is the Alt-Dot, which is yank last argument. So if you, for example, I don't know, touch, I'm just going to create an empty file here. I'm going to make a directory, example. I'm going to move that because I didn't quite name that what I wanted it to be. Example foo.sh is a better name for it. And now I want to cd into this example directory. Maybe this path is really long. I don't want to have to type that out by hand all over again. Alt-Dot is going to be a really convenient shortcut for me. So I'm going to hit cd space. That's the command that I intend to run. I'm going to press Alt-Dot, and what it's going to do is it's going to cycle through all of the last arguments of each of the commands that I've recently run. So first it's going to show me example/foo.sh. That's not exactly what I want. And then it's going to show me foo, and then it's going to show me example. And example is the one that I want. So I'm going to press Alt-Dot, Alt-Dot, Alt. Oh, no. So yeah, ignore that one. That wasn't actually a command that I ran. So it showed me cd example. And then I didn't have to type the path all over again because it was the last argument in something that I recently ran. So maybe you're editing a file and you want to later like run that file. So if you were to open this in an editor like foo.sh, and now this is there's something in it like that. And if I want to run that file, maybe I don't want to type the whole file name all over again. I could just, for example, bash bash alt dot, and it would fill in the last argument from my previous command, which is the file that I had just edited. In addition to just being able to crawl through history, for example, the history command prints your entire history recorded on your machine, it's very useful to preserve even more of your history. The defaults for a lot of these configurations came from a time in computing where storage was extremely limited. Plain text, especially on modern machines, you can fit many, many thousands or millions of lines of history on a fairly low-powered machine these days. So we do recommend, and these slides will be uploaded to the Scale website. So if you look at my talk on the Scale website, you can download the slides, so you don't have to manually copy the text out of these. But if you were to put this in the .bashrc file in your home directory, it's going to do two things. One is it's going to change the location of your history file to this bash history actual. That gives us a little bit of insurance in case your personal configuration is only partially applied, then we're not going to clobber all of your carefully curated history. And it's also going to change the size of the history. So instead of the default, which is just a few thousand lines of history, we're going to store, this is what, like 1 million lines, and we're not going to impose any limit on the total size of the file. Oh, and a third thing that we're doing here, so prompt command is a special variable in bash. It's going to run whatever is set inside of prompt command every time it shows you your prompt. So I'm running two things. I'm running history-a, which will immediately save the history from my current buffer. And then I'm going to run whatever else was configured as the prompt command. It's important to note the history-a here. If you're running a bash session, the commands that you've typed aren't immediately saved into your history file. In order to get that to happen, you either need to exit bash gracefully with Control-D or with the exit command or by logging out normally, or you can run history-a. So history-a here as part of the prompt command is extra insurance that any commands that you've recently run are going to be saved to history, even if your session dies or bash quits unexpectedly or the server crashes and bash didn't have a chance to exit successfully. And then finally, we're just telling bash to, whenever you write history, just always write it to the end of the file. That helps keep things chronological in the history file. In addition to the commands that you run, it's also worthwhile to keep the history of the output of those commands. So I'm using tmux primarily as my terminal command. So let me run so here I'm going to print out the numbers 1 through 1000. I'm going to print out an important string, and then I'm going to print out the numbers 1 through 1000 again. This is just an artificial example. Like you're scrolling through the output of a program, it dumps an awful lot of output, and you saw something flash by briefly that was really important to you. So in your own terminal, you want to be able to scroll through as much history as possible. 2,000 lines might seem like a lot, but in terms of the amount of memory and storage that's required, loading a reasonably complex web page on a web browser is going to be orders of magnitude more data than just adding like hundreds of thousands of lines of scrollback history. So as I scroll backwards with my mouse wheel in this case, I can find, oh, there is the important string right in the middle of my scrollback history. This is going to be configured in one of two places or in both of the two places. Number one, it's going to be in whatever terminal multiplexer you're using if you are using a terminal multiplexer. So in the case of vanilla tmux, it's just .tmux.conf in your home directory. Or in the case of byobu, it's going to be in the .byobu directory and then in the file profile.tmux. So that's the command you would add to that file in tmux to configure it. Or if you're not using a terminal multiplexer, then look in the configuration options for whatever terminal you're using that's part of your operating system. So in iTerm and PuTTY, I'm using console on some of my Linux machines. It'll be in the configuration options there. Let's dive a bit more into some of the shortcuts. There are a couple layers of shortcuts that are accessible when you're using a standard terminal connection. The first layer that gets in line is STTY. This controls the actual serial port, like virtual serial port connection that's established when you have like SSH or a terminal emulator up and running. Probably the most convenient shortcut is Control-C. If you're running a command like sleep infinity, and you decide you don't want to run that command anymore because, in fact, this one will never exit, you can hit Control-C, it'll kill that command, and, well, more precisely, it'll interrupt that command, and then that command will try and exit gracefully. If a program needs a little bit more convincing in order to exit, we have another signal that we can send. Control / sends a sig quit. Control / is going to quit, and you'll also notice that it dumped a core. This is a snapshot of the memory of that application. So you see that this is saved somewhere in particular on the system. So if you needed to debug it later, you can check out the snapshot of memory in a debugger. Control-Z suspends an application. So if I didn't want to quite kill this sleeping for infinity, I can hit Control-Z, and we'll talk about job control a little bit later. So I'm going to kill that in the meantime. Control-S and Control-Q start and stop the actual serial connection. This is about like rate control in a serial connection. I don't find these to be useful at all in modern-day terminals. They exist for historical reasons, but the important mention here is that Control-S conflicts with the history searching from a few slides ago. So Control-S is that forward searching, which is similar to Control-R, but STTY is going to get in the way first. And in order to prevent that STTY from getting in the way, we recommend that STTY-IXON be added to bashrc. That'll disable the functionality for this Control-S, Control-Q stopping and starting of the actual terminal serial connection itself. So after the communication happens inside the serial terminal connection, then we have Readline. So Readline is a library that's used by lots of different utilities. Bash uses it for the actual text interface as you're typing commands. So does, for example, the MySQL client. So as you're typing a SQL command in the MySQL CLI, it also uses Readline in order to accept input from the user. There's a whole series of shortcuts that are available for Readline. A great number of them are inspired by the shortcuts that are available in the Emacs text editor. There is a mode for Readline that you can enable in its configuration to make it behave more like VI or Vim. Check out the man page if you're interested in doing that. But in general, since I work with a lot of machines that I don't personally control, I find I like to use the default shortcuts. The first shortcut on this list is my absolute favorite. It's the undo button. So say, for example, I had this sed example, this sed command, and I pressed backspace. I'm trying to erase my comment, and oh no, I've just erased too much. I didn't mean to do that. I need to undo. So Control-Shift-, that is, I'm typing a control underscore. That's going to undo whatever recent change that I've made to the text of the command. So I can hit that just a few times, and there we go. That's as much as I wanted to actually delete. I find the undo button to be so convenient and yet so obscure. People have been working with, I know people who have been working on the shell and on the command line for over a decade who have never encountered it because it's actually pretty hard to discover these if you don't already know like where the documentation for them is. So we have a few additional shortcuts that I like to highlight. Control-W and Alt-Backspace have to do with erasing whole words at a time. So in this sed example, instead of like holding down the backspace key to erase just a few characters at a time, I can hit Control-W a few times. And what it's going to do is it's going to erase the text one word at a time. So Control-W erases example, Control-W erases sed, and Control-W erases that hash and the space. Control-W again erase that entire text string. Alt-Backspace behaves very similarly, but it considers different characters to be parts of words. So here, if I press Control-W, it's going to erase everything that's part of this regular expression, including the apostrophe that starts out the quoting part. But if I press Alt-Backspace instead, it's going to erase a portion of the regular expression, and if I press it again, it'll erase another portion of the regular expression. So it uses different characters to delimit words. Okay, so I have to keep the text editor near the top of the screen so that everyone can see what's going on through the heads of the crowd. Thank you for the feedback. Cool. So here, Control W erases words at a time, and Control W again will erase my entire regular expression. And then undoing that and using Alt backspace instead, I'm going to erase the G apostrophe, and then I'm going to erase everything up to the next apostrophe. So it uses a different separator for each of the instances of either Control W or Alt backspace. Control A and Control E jump to the beginning of the line and the end of the line respectively. If you don't feel like using the home and end keys on your keyboard because they're relatively far away from where your hands are laying naturally in a typing position, you can use Control A and Control E to more easily get to the beginning or the end of the line. And there are analogous shortcuts for deleting to the beginning or the end of the line. So if I press Control K, it's going to delete everything from my cursor to the end of the line. Or if I go back to that position and I press Control U, it's going to delete everything from that cursor position to the beginning of the line. These are just more convenient, like you have an interesting command and it has a huge like path name at the end, and you just want to like jump into the middle of the command, erase that whole block of text. Scrolling to the right position is relatively safe. You don't have to do anything special. You just scroll into exactly where you want in the command line, hit Control K, and then it's cleared out whatever you like. So I mentioned Alt dot, that last one on the slide, during the talk about history, so I don't need to go over that one again. But the other two that I like to highlight are quoted insert and editor. Quoted insert is interesting. If you ever want to get, for example, a literal tab character to appear inside of the input of a command on the command line, if I press tab, that's going to autocomplete some file names because of bash completion, which I'll mention later. But I wanted to type an actual tab character. I didn't want bash to fill in something or to run some other kind of shortcut. So I'm going to use a quoted insert. That's the Control V. At first, it's going to do nothing. But if I type a tab, now it's going to interpret that tab literally instead of trying to interpret that tab as a shortcut in the command line interface itself. And now that tab is part of the argument for echo. Editor is also a neat one. So my editor, I don't think I have it set. I'm just going to set my editor to be Vim. And now if I have a long and complicated command, maybe I want to do something more sophisticated. I want to edit the command in a text editor, in a real text editor, rather than just Readline. If I press Control X, Control E, it's going to open the command in this case, I've just set it to Vim. I can edit that command. And then when I save and exit, it's going to run that command. So this is a more convenient way to make large modifications to a particularly complex command. And similar to the topic of the question? Yeah, the slides are available for download. If you look at my presentation page on the Scale website, it'll be right underneath the description of this presentation. There will also be a link to that at the end. So ASCII has some historical some historical context. ASCII is the default character encoding. And what I want to highlight with the ASCII man page itself, and I really mean looking up ASCII in the manual, pressing Control actually modifies the character that's sent through the terminal. Assuming that it's not already a shortcut in STTY or Readline or anything else, then Control followed by a character, for example, Control I, is going to subtract 64 from the value of that character, and I'm going to actually get a, in this case, horizontal tab. So let me dive back in. If I was typing that same echo with the tab command, if I press Control I, it's going to be interpreted exactly as if I had typed a tab character. There are a few, let me go back to the man page. There are a few characters, for example, if a major hardware manufacturer decides that they don't need to include an escape key on a keyboard, you could use Control open square bracket to type an escape character. So that way you don't need to rebind something else to escape if you know that you can just type Control open square brace. Likewise, that's how you can find, for example, that the backspace key is actually Control-H, because if you look back in the man page and you scroll down to H, that's actually the backspace key. And I've mentioned that we have auto-completion. So Bash has some really nice features for completing what it thinks that you want to type. So right now, I have a single file in this directory, foo.sh. If I wanted to edit this file, it's very easy for Bash to try and guess and help me out in deciding what files I want to edit. So if I want to run vim, for example, and I want to edit a file, I can start typing that file name. But instead of typing the rest of the name, I'm going to press Tab. Bash is going to look at all of the files in this directory, and it's going to suggest, oh, did you mean to edit? I've just pressed Tab, foo.sh. And it finished typing the rest of the file name. I didn't have to do that. It works also with directories. So if I wanted to cd into a directory, if I wanted to cd to the example directory, if I type E and then Tab, it suggested to me that example is a possible completion of that. But if I wanted to use my editor, there's a slight difference. I actually have multiple file names that contain E. There's a customization here. You'll notice that normally file names are case sensitive. I have a customization, which I'll talk about in a little bit, that makes this tab autocompletion case insensitive. But the important thing to highlight here is, in the case of editing a file in this particular directory, Bash doesn't know whether I want to jump into the example directory or to edit the example2 file or the example.sh file. This wasn't a problem when I used cd, E, and then tab, because it's aware that the cd command likes to work on directories and not files. So the Bash autocompletion is actually pretty sophisticated. There's customization that you can do. For example, git, and if I press tab, it will also try to autocomplete. So this autocompletion is very context sensitive, and in many utilities, you'll find that it's much easier to navigate all of these different command line options and arguments if you can make use of the Bash autocompletion feature. Check out the man page in the Bash completion section. So if you go to man bash and scroll down to Bash completion, it'll give you a lot more documentation about how this completion is implemented and how to add your own support for your own utilities. So let's talk about customizing the shell, getting some convenience features up and running. I personally like to set my key repeat configuration to have like the maximum repeat rate and the minimum delay. That's partially because I can undo things pretty easily when I'm typing things on the command line. And sometimes I have an extremely long command, and I want to be able to scan back and forth. So if I have the repeat rate set to be very high, then I'm not waiting a very long time to scan to the front or back of this line by holding the keyboard character, by holding the key on my keyboard. So this would be in your local operating system's configuration. Look in the system settings underneath whatever keyboard configuration options you have, and you can tune these variables accordingly. This setting is not for everybody, but I personally like it. Also, take some time to customize the colors and fonts of your terminal. Find colors that are comfortable for you. A lot of people love dark mode. In presentations, I like to use light mode, and then I use dark mode in my terminal later on. If you like more contrast, set more contrast. If you like less contrast, set less contrast. Try and make it comfortable for you. When choosing a font, again, find something that's comfortable. I have a couple examples on the slide. The slides use the Menlo font, but I also really like Hack and Ubuntu Mono. The important thing about is find something that's, number one, readable, and number two, gives you the ability to distinguish between similar characters. So it's very easy to confuse a capital O and a 0 if the fonts look identical, but if they give you some kind of hint with like a slash or a dot that they are different characters, it'll reduce the risk of typos or misinterpretation later on. Another customization in Bash is to customize the prompt. So PS1 is a little string and syntax engine that runs to display the prompt for your shell. So if I'm in Byobu, it gives me a little bit of context about what's happening right now. So it highlights, this is part of the Byobu default configuration. It highlights my username in one color, it highlights the host name in a different color, and it highlights the directory in another color. So my username is blue, my host name is red, and my directory is green. This gives, color is a great way for humans to distinguish different pieces of text in context. Byobu also provides exit code highlighting. So I'll get into a little bit more detail in a few slides, but sleep 1 is going to exit successfully, and so it doesn't need to tell me any additional information. But sleep infinity, followed by me killing it or telling it to interrupt by pressing Control-C, that's going to tell me that, oh, this was not a successful command. It actually exited with exit code 130. The actual output, it only showed me a little ~C for Control-C. If I had a command like false, there's no feedback on the terminal besides what I've configured in the $PS1, that Byobu has configured in the PS1 to tell me that false actually didn't do what it didn't complete successfully. For additional configuration options, check out the man page for bash and scroll down to the prompting section. Another popular customization for your prompt is to include some context about your version control system. So it's fairly common for your prompt command, or rather for your PS1, to include some information about which branch you're currently checked out on, or if you have any local changes that haven't been committed yet. Check online for additional customization options. Lots of people online have written recipes for you already. So some of the other customization has to do with Readline itself. The configuration for Readline is going to be set in the .inputrc file in your home directory. The man page for Readline gives detailed descriptions about what each of these things do, so I'll just highlight a couple of them here. So blink matching paren, if, for example, I have, if I close the parenthesis here, what it's going to do is it's going to flash the opposite parenthesis. It's going to show me which one matched. When I have a single layer of parentheses, that's not so interesting. But if I have multiple layers, like I have some square braces open and curl braces, and then I want to close the curl brace, it actually gives you a little bit more context. Okay, what actually matched the character that I've just typed? And so you can be, this is a way of reducing typos even further, because you get some feedback about how things line up in the command itself. So I mentioned that the auto completion is normally case sensitive, but I've configured it to be case insensitive. That's this option completion ignore case on. You can check out the man page for additional details about all of these configuration options, and I would recommend actually reading the man page before copying and pasting this into your own config, because some of these change the behavior of the shell in ways that you might not expect at first. So actually check out the man page. It's meant to be read by normal human beings, so you can find out what all of these things actually do. If you have some commands that you type fairly frequently, or some options on commands that you use very often, you can use aliases and functions. So 3 examples that I have. So this is how you would, I'm going to give 3 examples of things that I do fairly often, and then in the next slide I'm going to show you how to make those more efficient. So the IP command is really cool. It shows you information about, in this case, all of the IP address interfaces that are available on this machine. But as a human being, it's hard for me to read, okay, which part is the IP address? I have more than one interface here, so this is the IP address, and this is another IP address. It's hard for me to visually scan this. So more often than not, when I run the IP command, I actually would prefer to run IP-C, which enables color mode. So now the output is color-coded, and it's much easier for me to see as a human being, oh, this is an IPv6, this is an IPv6 address, this is an IPv4 address, here are some MAC addresses. So I want to be able to just if I had my way, I would love to be able to just replace the IP command and always run it with the -c option. I can do that with an alias. Awk is another neat command. So awk is a language unto itself. We'll mention a little bit later. But awk, let's do here, print $3. Let's go and do proc mounts. So this awk with print $3 is going to print the third column of proc mounts. I could replace this number. So if I wanted the second column, I can use a $2. This is just it's pretty frequent that I like to extract a particular column from a file when the columns are separated by white space. So I'm going to make that more efficient in a moment. And also, it's also pretty common. Like I want to make a directory like cool, and then I want to cd into that directory. I've just made the directory. I probably want to go in that directory. So I want to cd into cool as well. So let's make these more efficient. So this is what you would put in your .bashrc, for example, to create shortcuts for each of these options. So the alias IP is equal to IP-C means that anytime I run IP, it's going to be transparently replaced by IP-C. So now, whenever I run IP-A, it's always going to give me color, and it's always going to be easier to read. This field, so this is a function. Functions can be slightly more sophisticated than aliases. So this function is going to do something a little bit more convenient. So I can pass in the column number that I want to affect as an argument onto field, and that will be substituted inside of the awk script. So now field 3, taking input from proc mounts, prints the third field, and then field 2 prints the second field, and so on. And then mkcd. So this function is going to take an argument, it's going to create the directory, and then it's going to cd into that directory. So mkcd cool2 is going to create that cool2 directory and then immediately cd into it. So you can create any kinds of shortcuts that you like with aliases and functions. Let's talk about some of the cool command line tools and utilities available. So the GNU core utils are a fantastic collection of utilities, just general purpose utilities on the command line. I want to highlight a couple here. So I'm going to use my field script from before to show you a couple things. So the third column in proc mounts tells me the type of the file system that's mounted for each of the mount points in my system. They come in whatever order that the mount kernel utility considers convenient. So if I'm consuming this as a human, maybe I want to see the items in sorted order. So if I pipe anything into sort, it'll give me the elements in sorted order. There's also a unique command, and you can string that together as well. So now unique, its entire purpose is to eliminate adjacent duplicates. So it has done exactly that. I no longer see so many squash FSs in the output. But that's actually not the best way to do this. Sort has a -u option, which will do exactly the same thing. But maybe I'm not interested in the list so much as I'm interested in how many of each I have. So unique has some options that sort does not. Unique -c will print out in front of every line the number of times that that text has appeared in the output. So I can see that I have 8 squash FS file systems in this case. But maybe I want to sort that again because I want to see the things that are most frequent. So I'm going to pass that into sort again with the -n option. This means that it's going to sort these numerically. So by default, like 1 comes before, or sorry, 2 comes before 10. Sorry. By default, 10 comes before 2 because 1 comes before 2 because that's the first character. When you sort things numerically, it's going to interpret the first field as a number. So now I see if I've run with sort -n at the end that my most common file system on this machine is actually cgroup. This idiom of using sort pipe unique-c pipe sort-n is an illustration of how powerful these commands actually are. If you had to write a C program to do the equivalent, you'd be having a pretty hard time. And compared to writing just a few pieces of text in bash, that seems a lot easier. Column is another really cute command. So if you have a list of, let's actually go 30 of those. So if you have a long list, like the output of the ls command, everything appears in nice, neat columns. That's empty, so there. So ls prints things out in nice, neat columns. It tries to conserve space on your terminal as much as possible. So if I have a command that prints out very short pieces of text that I'd like to read in columns, I can instead pipe that into column, and it prints them out in nice, neat, compact columns. That's not actually what I use column for most frequently. I actually use it for, let's find this. So this is a little bit complicated of a regular expression. Don't worry about it. But what I'm going to do is it's just going to print out all of the elements from my fstab configuration file. This configuration file uses white space to separate each column, and in its default formatting, it's pretty hard for a human like me to read. If I pipe that into column-t, it's going to separate each of these columns in each of these fields into vertically aligned columns. So now this is much easier for me as a human to read and parse. The documentation for the core utilities are fantastic. There are man pages for each of these. You can check out the GNU website. There are also info pages for these, which go into much more detail than the man pages would normally. There are additionally lots of advanced tools on the command line that can do some pretty sophisticated things. Xargs and Parallel I sort of group together in my own head. What these two are designed to do is to take a long list of input and run it as arguments to a command. The example I have of this has to do with find. So let me jump into find, which is my second example. So find searches for files and directories. Pretty simple. I'm going to give it a path. In this case, I'm going to find inside of my pictures directory. And I'm going to do a case-insensitive search for any file name or directory name that looks like screenshot followed by any number of characters followed by .png. So in this case, it found a few screenshots in my pictures directory. I can then pass this into Parallel, for example, and run a very expensive long-running command. So optiping just recompresses the file, so it'll hopefully be a little bit smaller. The important bit here is that I'm passing the output of find into Parallel. And what Parallel is going to do is I have a fairly powerful laptop, and I have an even more powerful development machine remotely. It would be pretty terrible if I could, like I have a handful of files here. I want to be able to use all of the power, all of the different processor cores in the system to be able to churn through all of this long-running work. So if I were to run this using Parallel, now I get one separate instance for each of the instances. I get each instance of optiping, in this case, to run in Parallel. I've told Parallel to process 50% of my cores, which in the case of this laptop is 6 instances. And I've also given it the ETA option, so I have some live feedback about how long this is going to take, based on how long it's taken to process elements already. So I'm just going to kill that because we don't need to wait for it. PV is another favorite command of mine. It's designed to give you progress information about a pipeline or reading a file. In its normal use, let's do dev view random, and I'm going to pipe that, just discard that to dev null. So this is just going to read from one endless stream of random bytes and discard the output. But what PV is going to do is it's going to give me live feedback about how much data is going through the pipeline and how quickly that data is being processed. PV can do some pretty sophisticated things. So let me grab my example command. Just give me a moment because it's a little bit complex. So here I'm going to read this file. I'm going to decompress it, and I'm going to pass it to PV again. I'm going to compress it, and I'm passing it to PV again to save it. So this actually gives me context about each part of the pipeline as it's running and how quickly the data is being processed in each part. Unfortunately, I must have a typo, but this is some good context about how quickly a process is going to churn through data. Cool. Some more sophisticated utilities. I mentioned man and info before. If you are ever curious about like how does a command work, what are the additional options I can do with that command, the man command, so you just like, if you were interested in how bash works, man space bash would show you the documentation for bash. And some utilities, like the GNU core utilities, also have info pages. So info for less is going to give you even more detail about less and how it works. In this case, yeah. grep, sed, awk, and Perl are all heavily invested in regular expressions. This is a special language to be able to match or identify particular patterns in text. If you haven't been hugely involved in regular expressions before, they are a very powerful tool in command line utilities and in programming in general. It's a little bit difficult to get the hang of, but once you do get the hang of it, you can do some fairly sophisticated things with a fairly compact string of characters. If you want some resources to learn how to use regular expressions, I've got a couple sites here. Regexer is going to give you detailed information about, like you paste in a regular expression, you want to know how it works, it's going to give you detailed information about exactly what's going on inside that regular expression. And then regex crossword is a way to practice regular expressions. Let's talk a little bit about the shell. So I mentioned that shell commands have exits statuses. So the true command does nothing, and it does that successfully. Byobu is going to be especially illustrative in these examples. The false command is going to do nothing, but it's also going to fail at doing that. And by fail, I mean it's going to output nothing, but it's also going to set its return code to 1. Anything other than a 0 as a return code is considered unsuccessful. You can string commands together. So if you use a semicolon to string commands together, then each command will run in sequence, regardless of the exit status of the previous command. This is an extremely dangerous command to use, however, because what if, for example, I don't have an SD card mounted in this machine? It's going to run the CD command, that CD will fail, and then it's going to run the RM regardless of where I am in my file system. Like if I'm in my pictures directory, that's not going to be a great situation. You can string commands with an ampersand, in which case it will only run that second command if the first command succeeded. It can get a little bit complicated to string commands together using the and the or options, but just be aware that you can string them together in that way. Likewise, isn't it curious that when I have sleep infinity, if I hit Control-C, it's not like a 1 that gets outputted, it is a very particular number. So in this case, 130 is actually, it corresponds to the signal that was sent to that process. So if I look at what signals we actually have available, sig_int is number 2, and it just so happens that 130, which was the exit status, is 128 more than the signal that was sent. So this is actually a way to tell like what kind of signal might have been sent to that process. If you ever want to see the exit status, if you ever want to use it later on in a script, it's in the $? variable, and you can use that in a bash script later on. It's also worth mentioning pipe status. Because it's perfectly possible for some part of a pipeline to fail, even though the first and latter parts actually succeeded. If you ever need to detect that, there are two ways of doing it. The pipe status array in bash contains the exit status of everything in the previous pipe that ran. And also, if you're writing a script, which we'll get into later, you can also set the pipe fail option, which would abort the script in case something in the middle of a pipe failed. Job control, let's dive into that. I have just a few minutes left. So I have a long-running command, which will actually take forever to finish. So I want to continue using this terminal, but I also don't want to kill my long-running command. So what can I do? I'm going to type a Control-Z, and that's going to stop the command and push it into the background. So now the command is stopped. I can resume that command in two ways. I can either use FG to bring it back into the foreground so I can continue watching it, or if I push it back into the background again, something that's stopped isn't actually progressing. If I want it to actually keep processing data, I need to specifically background that process. So BG is going to push it into the background, and then that process is going to continue running and hopefully finish. So let me bring it back into the foreground, Control-C to kill it, and do this with a little bit more of an interesting example. So sleep 1, I'm going to immediately background that, so it's stopped. Because it's stopped, like sleep 1 is supposed to exit in 1 second, but it's stopped, and because it's stopped, it's going to continue running until I, for example, background it. And since I backgrounded it and more than 1 second has elapsed, then the program completed the rest of its processing. You can operate on particular commands, like the examples here were prefixed with a 1. So if you kill %1, that would kill that first job in the list. You can list all of the jobs with the jobs command, and if you want to launch many, many things and then wait for them all to finish, then you can use wait. Bash has a lot more sophisticated control flow. Some of the examples are on the board. I'm not going to dive into detail here. Just be aware that it is a programming language. You can do some pretty sophisticated things in it. I love Bash. I like to use Bash for very small scripts, but if you're doing something very sophisticated in Bash, like if you're writing a 1,000-line Bash script in a file, that's at a point where I would kind of suggest that you start looking at other languages, because really complex programs, Bash sometimes isn't the best choice for that. But if you are writing a Bash script, I want to give call out. So here, this is a safety option at the start of a script. It's going to do a few things. Set-E, if any command in your script exits with a non-zero status, it's going to kill your script immediately. It's going to stop processing. It's going to exit. That's great for safety. Like you can run cd and then dive into and then try to remove files from a directory. Set-E is going to protect you from that cd command failing and accidentally removing files where you didn't want to. The U option protects you against the use of unassigned variables, because if you try to use a variable that you didn't assign a value to, Bash is going to, in the case of this, rm-rf, let's do, if I didn't actually define what directory was, then this is a very dangerous command to run. Set-U is going to protect you in that instance. And finally, I'm going to highlight shell check. Shell check is an amazing project. It's a linter for Bash scripts, and it's going to parse through your Bash script, and it's going to give you advice about common mistakes, common errors, and in general, try and help you improve the quality of your scripts. One of the other engineers that teaches this class at Facebook likes to say that scripting without shell check is like driving without a seatbelt. You can do it, but you're not going to be safe. Thank you for attending this talk. I wanted to leave you with a few links, so if you can grab those, otherwise I'll put them on the slides. The link on the left is the slides for this talk. The link on the right is a link to engineering.fb.com. I will be around for a few minutes after the talk to answer any questions, but I think I am exactly out of time, so thank you for coming.